Okay, boys and girls, so we have been working on ratios, and we've been working on Unit 3. We've done Lesson 1, 2, and now we're on Lesson 3. Lesson 1 was ratios, just identifying ratios. Lesson 2 was creating equivalent ratios, and then Lesson 3 is a continuation of equivalent ratios. So our purpose today is mathematicians can identify and solve for a relationship between two quantities using ratios and equivalent ratios. And the key word for this that's different from previous ones is the word solve. So today you're going to solve for equivalent ratios. Now go ahead and pause your computer and go ahead and write our purpose, understand our purpose, and then we can continue when you're ready. Now, what is an equivalent ratio? Remember, first of all, a ratio is a comparison between two quantities, boys to girls, teachers to students, whatever it may be, chocolate chip cookies to banana muffins, and I'm just making up things right now. So equivalent ratios compare two things. That's a ratio. Equivalent ratios are two ratios who have equal values when simplified. So when they're simplified, they have an equal value. Some examples of equivalent ratios are 1/2. So maybe one dog to two cats. And if you have one dog to two cats, if you had two dogs, you would have four cats. If you had three dogs, you'd have six cats. If you had four dogs, you would have 8 cats. So these are equivalent ratios. Another way to find equivalent ratios is to have something 12/18. And it would be to simplify the ratios by finding the greatest common factor. So we would find the GCF. And this is an easy way to find equivalent ratios. So 1 times 12, so 12 is going to go here, 2 times 6, 3 times 4. And then on the other side, we'd have 18. So it'd be 1 times 18, 2 times 9, 3 times 6. So the value that they have in common would both be, they both have a 1, they both have a 2, they both have a 3, they don't have a 4, they both have a 6, they don't have a 12, they don't have a 9, and they don't have an 18. So the greatest common factor would be 6. And so we would divide both the top and the bottom by 6, and we would get 12 divided by 6 is 2, and 18 divided by 6 is 3. So these two are equivalent ratios. You can go ahead and pause it at any time so you can finish the notes and continue when you are ready. Okay, so today's activities are going to be pretty simple. They do get more complex and they get a little bit more difficult, but I'm going to do the first one for you. And so after that, you're going to go ahead and continue with the problems. So here is a ratio. Here is a ratio. This is a ratio. And the ratio is 2 circles, and if I point 2 circles, to 1 square. Now, we're supposed to have an equal sign here. If I am given 4 circles, so now I have 4 circles, what am I going to do? How many squares will I have? Well, for every 2 circles, I get 1 square. So I'm going to come over here, and I'm going to circle, or put a box around my 2 circles. And if you notice, 2 circles to 1 square. Now I have another set of 2 circles. 2 circles to 1 square. So if I have 4 circles, I would end up with 2 squares. So 2, and this would be 4. Now I want to just point something out. This isn't on this problem here. What if I had 1 circle? If I only had 1 circle, what would happen? If I only had 1 circle, well, if 2 circles, and we see 2 circles equals 1 square, 1 circle would equal half a square. So 1 circle would equal half a square. So 1 circle, I would draw a square, and I would cut it, and I'd shade in half of it, or block out half of it. Now the next problem, and the equal signs for some reason didn't show up on the first one, and it's here, but it kind of messed up. So the next problem, it is 4 diamonds to 1 square. 4 diamonds to 1 square, 4 to 1. Now if we look over here, now they're only giving us 2 diamonds. And this kind of goes back to what we're talking about up here. Now we have 2 diamonds. So 2 diamonds, if I had another 2 diamonds here, I would have a square, but I don't. I don't have 2 more diamonds. I have half of them. And so I'm going to go ahead and erase these. So since I have 2 diamonds, I'm going to have to cut this one in half, which will give me 2 diamonds. I have my 2 diamonds here. So if I'm going to cut that in half, then I'm going to have half a square. And so I'll just shade in half the square. And so it would be 2 to 1/2 or 0.5. These are the same thing. Now if I go to the next one, lightning bolts to clouds. Lightning bolts to clouds. This is where it gets a little bit more complicated. So we have 3 lightning bolts on this side. And how many lightning bolts do I have on this side? 1, 2, 3, 4, 5, and 6. So let's break them up into groups of 3, because I know I'm going to need 3 over here. So I'm going to have these 3, and I'm going to have these 3. And the easiest way for me to go about and figure out how many clouds am I going to have over here would be to break them up. And the way I can break them up is I could say, okay, this cloud goes with this group. 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 And we have one last cloud. This cloud goes with this group. So what is the ratio here? The ratio would be 3, 1, 2, and 3 to how many clouds? 1, 2, and 3. So it would be 3 lightning bolts to, and I'm just going to try creating a cloud here. 1, 2, and 3. So it'll be 3 to 3. Or if you look, there's 6 to 6. Okay, the next one. Sharks to cats. Now, this is my last one that I'm going to do with you, and then you're going to go and you're going to continue. So if I have sharks to cats, how many cats do I have? I have 1, 2, 3, 4, and 5 cats. And I'm going to erase all of that. But I only need, if we look over here, it's asking me the ratio of 1 cat. So let's go ahead and circle all the 1 cats. 1 cat, 1 cat, 1 cat, 1 cat, 1 cat. And then what I do with my sharks is I do what I just did. This cat gets this one. This cat gets this guy. This cat gets this guy. This cat gets this shark. And this cat gets that shark. So right now it's 1 cat to 1 shark. But I still have these guys right here. So I'm going to do the same thing. This shark goes over here. This shark goes over here. This shark goes all the way over here to this guy. This shark here is going to go right here with this guy. And then the last one, this one goes with this shark. So now all my sharks are taken. And what do I end up with? I end up with each cat will have how many sharks? Well, this cat has 1 shark and another shark, 2 sharks. So each cat will have 2 sharks. And I'm just going to write sharks because I don't know how to draw a shark. Now you're going to figure out here how many keys to how many locks. So you want to find out how many locks. You're going to keep going through how many smiley faces to sad faces. Keep going through and figuring these out. And then when you get to the ratio tables is where it's going to get a little bit more complicated. So go ahead and pause it, solve those, and then come back, and when you get to the ratio tables, we'll continue. All right, now we're on our ratio tables. In a ratio table, we're going to be using these quite often, but this is the beginning stages of us learning how to use a ratio table. So we're going to see that here's our categories. We have days and then inches of snow. So this means on one day, we got 3 inches of snow. Then we get 6 inches of snow, and we get 9 inches of snow, and we get 12 inches of snow, and 15 and 18. How would we figure out what goes in each box? How would we figure that out?